like to thank you for your time and tips during our study, and thank you for giving us the opportunity to stand up and talk in front of you. During the 15 minutes, we will try our best to go over everything in our project, and I wish our project is considered as one of the best projects in NKU. So we will try to cover the project goals, methodology, cost analysis, results, and discussion future work. When you look to this slide and this slide, you will definitely think about separation. So this is a missed picture, but not this. Basically, our project is to receive a bunch of objects and separate them and put it in the right spot. The small in the left, the big in the right. The easiest way to do this, just get workers and find a decent place. But that wasn't the best choice for us, because workers may get tired and they need some break. Workers need salary and healthcare. The percentage of error with the human is higher than machine. So we came up with the idea that we came up with the idea to solve the major issues for most companies, which are the time and money. When we're talking about the time, this machine could run 24/7. And the money, this machine just needs to be paid at once and do like maintenance 1 a year. So that's it. And since our machine works with the IR sensor, which means the sensor could count and separate at the same time. Let's see what's the behind the application. Since my major was hydraulic method, I was wondering if I can do something or move something naturally heavy by using rather than hydraulic or dynamic. And I know that there is a linear actuator can do that. But the problem is, how can I go wrong? I asked Abdul Nasser if he can go wrong the actuator, and he said yes, he can do it by the argument. So then our project started. Let's see the short clip.
Hello everyone. Hello everyone. This is our project. Hello everyone, this is our project. This is first actuator, and there is another actuator here. This is a sensor for big, and this is a sensor for small. Put control on, big, will go play. And if it's small, this will continue straight to the other box. Big. Again for this box. Small. We'll continue to the end. So let's go to see the LCD. It's here showing that only 2 and 2. 2 big, 2 small. Thank you.
Building the project. First step, the most important thing in our project is treatment. And our treatment has 2.2 horsepower and 10 miles per hour and 100 pounds per hour. Second step, design. Our design depends on these 5 steps. The first one is material and dimension. We use wood for our project because it's low cost and least friction with our project or with our target, and it's easy to cut and repair and maintain. And we have the dimensions 64 by 24 by 30 inches. The second one, thickness. Our project has either 30-quarter and half inches because we want our object to be light. The tower, we have 20 by 5.5 by 5.5 for the tower because we want the tower to fit the 4 samples for our target. The assembly line, as you see in this picture, the assembly line in our project in the right side because we want the object to fill down easier or faster. And since our object is 5 inches, so we need for the width for the assembly line more than 5. So we made it 5.5. Finally, the color. We have black and yellow to match the NKU logo.
Third step is the circuit. We need to list the components that we're going to use with. So as you can see here, we want something to push this side and this side. So we'll use 2 linear actuators with a speed of 9 inches per second. And this actuator working with 12 volt and 10 amps and 4 inches stroke because our object is 5 inches and we wanted to move it to the center, so it's 2.5. But 4 inches is more than what we expected. Second component is the Arduino. It's 5-volt operating. So when we talking about connecting the Arduino 5-volt to the actuator 12-volt, we will use a relay to communicate between the Arduino and the linear actuators. Since the actuator is a reverse polarity, so one relay is not enough. We will use 2 relays parallelly together to let the one actuator working in both directions. And since we use 2 actuators, we will use 4 relays is enough for these 2 actuators. And there's another way, thanks for Dr. Alama who told me about it. We can use only 3 actuators instead of 4 to save money for 2 actuators at the same time. Then we put them all together and we will use 2 power supplies. One is 12 volt, 10 amps for the actuators itself, and the other one is 12 volt and 1 amps for the Arduino. We wired everything up, then we brought the sensors to count and to detect big or small. These sensors are IR distance sensor with a range of 4 up to 30 inches, and it's a narrow angle, so it cannot detect more than 180 degree. So this is the best choice we got. The principle, I mean, you can see all of them sitting together that can cover up to 5 inches that we need here, because the actuator can move it 4 inches. The principle behind the IR sensor, there is at the right side is the detector and the emitter. So when it sends IR lights to the air, if there is nothing on the air, it will keep going. But if there is something, it will reflect back. By measuring this angle of incidence, will give you different voltage. And this different voltage means different distance. So last thing is the LCD, as you can hear, to monitor everything on our project. We get an issue because all of these, as you can see, the LCD, 2 sensors, and the relays, all of them in one Arduino, the power supply is not enough. So we used a backup battery, as you can see here. with 5 volt 1 amp. The cost overall for this project, 1,800. And as Yahya told you, that it's only need to pay once. So you don't have to, as workers' salaries each month. And regarding the maintenance, suppose one of these broken, the most expensive thing is the treadmill itself, and you can replace it. It's half of our project. So the hypothesis behind this whole project is to use this project with IR sensors communicating to the linear actuators itself. After all research and hard work, and thanks for all doctors who gave us this opportunity to brought this project. So, after all, in conclusion, these recommendations that we suggest to all users, the speed of the treadmill itself need to match the speed of the linear actuators, 9 inches per second. More than that will not fit. IR sensors are good for indoor uses, but for outdoor uses, we recommend to use ultrasonic sensors. Pneumatic and hydraulic actuators are good, but for heavier objects. This project can be modified in any place as the user wants. So suppose that we want, instead of having only 2 sizes, we want to have 4 sizes. Just increase the number of the sensors and you will get it. You want to separate between color differences, not sizes differences. Use the color sensors and it will fit.